All right, so hi, this is RNK Racaza, and I'm part of the um, group 4, which will be tackling about the chapter 5. And our topic for today would be advanced linear programming applications. So before we proceed with our subtopics, let me just share to you our objectives. The first one is to learn about the 4 new applications of linear programming. The second one is to learn the functionality of data envelopment analysis, revenue management, and game theory. The third one is to illustrate how these techniques were used to measure the performances of every institution. And the last one is to show how linear programming is used to design portfolios that are consistent with clients' risk preferences. Okay, so right now we'll proceed with one of our subtopics, which is the data envelopment analysis. So what is data envelopment analysis? This is an application of linear programming used to measure the relative efficiency of operating units with the same goals and objectives. So basically in a specific organizations, we have multiple inputs like the employee numbers, staff size, salaries, operating hours, expenses, and etc. So in this situation, it is often difficult for a manager to determine which operating units are inefficient in converting their multiple inputs to their desired outputs. So this particular event is where data envelopment analysis has proven to be a helpful managerial tool. Okay, so our example for today, in which we will be using the DEA or data envelopment analysis, is evaluating the performance of hospitals. So the hospital administrators at General Hospital, County Hospital, and State Hospital have been meeting to discuss ways in which they can help one another to improve the performance of their hospitals. So a consultant suggested that they will use DEA to measure the performance of each hospital relative to the performance of all 4 hospitals. Okay, so I need you to take note of this input measures and output measures. So for the input, we only have 3 examples or 3 inputs. The first one is the number of full-time equivalent non-physician personnel. Second one is the amount spent on supplies. The third one is the number of bed days available. And for the output measures, there will be 4. So the first one is the patient days of service under Medicare. Second one is patient days of service not under Medicare. Third one is number of nurses trained. And the last one is number of interns being trained. So I need you to check the table 5.1. This is the annual resources consumed, or basically the inputs by the 4 hospitals. So for the general hospital, we have 285.20 for the FTE non-physicians or their personnel. For their supply expense, we have 123.80. And for the bad days available, we have 106.72. And then for the university hospital, we have 162.30 for FTE, supply expense 128.70, bed days available would be 64.21. And for the county hospital, we have 275.70 for the full-time equivalent non-physicians. For the expense, for the supply, we have 348.50. Bed days available, we have 104.10. And the last one is the state hospital, in which we have 210.40, 154.10, and 104.04 respectively. So first, using a linear programming model, we need to construct a hypothetical composite. So in this case, a composite hospital. So I need you to remember that the output of the composite hospital is determined by computing the weighted average of the corresponding outputs for all 4 hospitals. And then the input of the composite hospital is determined using the same weights to compute a weighted average of the corresponding inputs for all 4 hospitals. So by the way, guys, the output and input for this, for the hospital that we will be evaluating later on would be a different process. So yeah, we'll see for that. And then the constraints in the linear programming model require all outputs for the composite hospital to be greater than or equal to the output hospital, the county hospital, so the hospital being evaluated. So we will be using the county hospital here as the hospital that we will be evaluating. Okay, no other, no more, no less. And then if the inputs for the composite hospital or for the composite unit can be shown to be less than the inputs for county hospital, the composite hospital is shown to have the same or more output for less input. So in this case, it shows that the composite hospital is more efficient than county hospital, since um, the composite hospital will just be requiring less input to produce more outputs. Okay, so it's like um, a win and win scenario for the company to have this kind of example. And then, in other words, the hospital being evaluated is less efficient than the composite hospital. If ever, the composite unit will turn out to be less than the inputs for the county hospital. Okay, so the DEA linear programming model, to determine the weight that each hospital will have in computing the outputs and inputs for the composite hospital, we use the following decision variables. So WG for the weight applied to input and output for general hospital, WU for the university hospital, WC for county hospital, and WS for state hospital. And then the DEA approach requires that the sum of these weights is equal to 1. Thus, the first constraint that we will be able to have is WG plus WU plus WC plus WS is equal to 1. Okay, so right now we have the table 5.2. A while ago, the table 5.1 shows the input for the for hospital, and right now we will be checking the outputs for the for hospital. So remember the four measures that I have discussed a while ago. This is the output for it, and then the input, that's the one that we have discussed a while ago, the one that is having 3 examples. Okay, for the output measure, we have Medicare patient days. For the general hospital, it shows 484.14. For non-Medicare, 43.10, and nurses trained 253. And the interns trained they have is 41. For the university, Medicare patient 34.62, non-Medicare 27.11, nurses trained 148, and interns trained 27. County Hospital has 36.72, 45.98, 175, and 23, respectively. And for the state hospital, for Medicare, 33.16, non-Medicare, 56.46, nurses trained 160, and interns trained 84. So in general, every DEA linear programming model will include a constraint that requires the weight for the operating units to sum to 1. So the same as what we did a while ago. As stated, for each output measure, the output for the composite hospital is determined by computing a weighted average of the corresponding outputs for all 4 hospitals. So for instance, the output measure 1, let's just say the number of patient days service under Medicare, the output for the composite hospital is, so you'll be totaling all of this, like, Medicare patient days for general hospital, plus Medicare patient days for university hospital, plus Medicare patient days for county hospital, and adding the last one, which is coming from the state hospital. So substituting the number that we have, we obtain the following expressions for the Medicare patient days. It would be 48.14 WG plus 34.62 WU plus 36.72 WC plus 33.16 WS. So for each of the 4 output measures, we need to write a constraint that requires the output for the composite hospital to be greater than or equal to the output for county hospital. So thus the general form of the output constraint is output for the composite hospital should be greater than or equal to the output for county hospital. Okay, please take note that the logic of a DEA model is to determine whether a hypothetical composite facility can achieve the same or more output while requiring less input. So if more output with less input can be achieved, the facility being evaluated is judged to be relatively inefficient, since the composite hospital is, you know, greater than the county or the hospital that will being evaluated. So, um, in layman's term, we'll just try to um, analyze that in order for a specific hospital to work, they need this specific output, I mean input, to obtain this kind of output. However, what we need to have here, or what we need to see, is that if the composite hospital is having a result that has a less input for the sake of having more outputs, then that means that the hospital that we are being evaluating is like having problems, or might as well, basically it's relatively inefficient, since the composite hospital, or the example that we have, is already greater than it, or great already greater than the county hospital specifically. So the table 5.1, relationship between the output measures for the four hospital and the output measures for the composite hospital. So just please, right now I need you to forget the three input measures, since we will be only focusing the output, which is the one that is having four examples. So because the number of Medicare patient days for county hospital is 36.72, as you can see under the WC house. So Medicare 36.72, the output constraint corresponding to the number of Medicare patient days is 48.14 WG plus 34.62 W plus 36.72 WC plus 33.16 WS is greater than or equal to 36.72. So this is like the other one, or the constraint that we have for the composite hospital. This is the one that you can see under the composite house, the first row, plus 33 point, 36.72, which is the first one that is under the county house, or the WC house. Okay, so in a similar fashion, we formulated a constraint for each of the other three output measures, with the results shown 43.10 WG plus 27.11 WU plus 45.98 WC plus 56.46 WS is greater than or equal to 45.98. For this, this is the non-Medicare, guys. Okay, the same process is what we did for the first with this first example. And then for the nurses trained, we have 253 WG. I'm referring to the third row, the third one under the composite house. So it's the 253 WG plus 148 WU plus 175 WC plus 160 WS is greater than or equal to 175. So the same example is what I have under the WC house. So the third one. And then the last one is the intern strain. 41 WG plus 27 WU plus 23 WC plus 84 WS is greater than or equal to the 23, the last one, or the fourth one that is under the WC house. So that's basically our constraint for each of the other three output measures. So the four output constraints require the linear programming solution to provide weights that will make each output measure for the composite hospital greater than or equal to the corresponding output measures for county hospital. Thus, if the solution satisfies the output constraints, the composite hospital will have produced at least as much as each output as county hospital. Next, we need to consider the constraints needed to model the relationship between the inputs for the composite hospital and the resources available to the composite hospital. A constraint is required for each of the three input measures. The general form for the input constraints are as follows. So by the way, guys, we are already done with the output constraints. So this is, this specifically for the Medicare patient days. Okay. Right now, we will be focusing on the input constraint. So the input constraint are as follows. Input for the composite hospital is less than or equals to the resources available to the composite hospital. So for each input measure, the input for the composite hospital is a weighted average of the corresponding input for each of the four hospitals. Thus, for input measure 1, the number of full-time equivalent non-physicians, the input for the composite hospital is, so the FTE non-physician for composite hospital is equal to FTE non-physicians for general hospital plus FTE non-physicians for university hospital plus FTE non-physicians for county hospital. And the last one is adding the FTE non-physicians for state hospital. So we will be substituting the values. We obtain the following: 285.20 WG plus 162.30 WU plus 275.70 WC plus 210.40 WS. So here are the inputs. To complete the formulation of the input constraints, we must write the expressions for the right-hand side values for each constraint. E is equals to the fraction of county hospitals input available to the composite hospital. So I need you to check the table 5.2, guys. This is the relationship between the input measures for the four hospitals and the input measures for the composite hospital. So this table shows the number of FTE non-physicians used by county hospital. Okay, as you can see under the WC, the first one or the first number that you can see is the 275.70, which is on the FTE non-physicians. Thus, 275.70E is the number of FTE non-physicians available to the composite hospital, okay, with a E. So if E is equals to 1, the number of FTE non-physicians available to the composite hospital is 275.70, just the same as the number used by the county hospital. However, if E is greater than 1, the composite hospital would have available proportionally more non-physicians, whereas if E is less than 1, the composite hospital would have available proportionally fewer FTE non-physicians. So because of this effect that E has in determining the resources available to the composite hospital, E is being referred to as the efficiency index. So right now we can now write the input constraint corresponding to the number of FTE non-physicians available to the composite hospital. So 285.20 WG plus 162.30 W plus 275.70 WC plus 210.40 WS is less than or equal to 275.70E. By the way, guys, if you will be asking to me where did I got this number, I need you to let me just try to emphasize here. One moment. Okay, so I got this number here for the 275.70 FTE non-physicians. And then we will be combining all of this for here. Okay. And then we will be plus 210.40, which is this. By the way, guys, we need to focus only on the county hospital since this is the hospital that we are trying to evaluate. Okay, and then in a similar manner, we can now write the input constraints for the supplies and bed days available to the composite hospital. So the same drill. A while ago, it's the 275 we have here 275.70, and then over to the 275.70E for the composite hospital. And then similar manner, 123.80 WG plus 128.70 WU plus 348.50 WC plus 154.10 WS is less than or equal to 348.50 E. So you can see here on the supply expense under the WC. Let me just emphasize here once again. Here it is. Okay, so combining all and then less than or equal to 348.50 E. All right, the same drill as what we have. It would be 106.72 WG plus 64.21 W plus 104.10 WC plus 104.04 WS plus 104.10 E. Okay, let's check. Yeah, here it is, the second one. So if a solution with E is less than 1 can be found, that means that the composite hospital does not need as many resources as county hospital needs to produce the same level of output. Okay, the objective function for the DEA model is to minimize the value of E, which is equivalent to minimizing the input resources available to the composite hospital. Thus, the objective function written is written as minimizing E or mean E. The DEA okay, so if E is equals to 1, the composite hospital requires as much input as county hospital does. So basically, there is no evidence that county hospital is inefficient. However, if E is less than 1, the composite hospital requires less input to obtain the output achieved by the county hospital. So the composite is more efficient than county hospital do, or basically we can see that the composite is um, better. I mean, more efficient or better than county hospital in terms of the input and outputs. So therefore, county hospital can be judged relatively inefficient by the time, if ever we have less input to obtain the output. Okay, so the EA linear programming model for the efficiency evaluation of county hospital has 5 decision variables and 8 constraints. It is rewritten as follows. So all of this information here, guys, are um, the expressions that we have made a while ago. So minimizing E, and then we have WG plus W plus WC plus WS is equals to 1, the first one. 48.14 WG plus 34.62 plus 36.72 WC plus 33.16 WS is greater than or equal to 36.72. And then, yeah, this is for the output measures. This first 48.4. I mean, let me just emphasize this once again. So this first 4 here, they are for the output measures. Okay, output measures, and then this 3 here, this is for the input measures. And then the last one is E, WG, WU, WC, WC, I mean WS is greater than or equal to 0. Okay, so we first note that the value of the objective function shows that the efficiency score for county hospital is 0.905. So this score tells us the composite hospital can obtain at least the level of output that county hospital obtains, having, no more than 90.5%. Thus, in regards with this one, we can see that the composite hospital is more efficient than and the DEA analysis identified county hospital as being relatively inefficient, since the composite hospital was able to um like was able to outgrow its percentage rather than the county hospital per se. So the composite hospital is formed from the weighted average of other three hospitals. The other three is WG is equals to 0.212, W is equals to 0.260, and WS is equals to 0.527. So clearly the composite hospital is more efficient than county hospital, guys, and we are justified in concluding the county hospital is relatively inefficient compared to the other hospitals in the group. So having this kind of result, the management coming from the county hospital or the hospital administrator should examine operations or other way to determine how county hospital resources can be more effectively utilized.